I'm going to start this little mini lesson with just a really quick why does it work for the series formula. It really doesn't take too much, and it kind of should remind you of how we derive the arithmetic sequence formula or series formula as well. It's got a slightly different twist to it, but same sort of approach. I'm going to take Sn, and if I look at Sn as a straight, let's write out what that sequence would look like. It would be U1 plus U1R plus U2R squared. That's not right, is it? Yes, it is. Plus dot, 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 dot. No, sorry, my bad. Plus U1R squared plus dot, 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 all the way to U1R to the power of n minus 1. That's how the sum works, right? Now, here's the trick. I'm going to multiply Sn by R. So that gives me U1 times R. So I'm looking at that term, and I've multiplied it by R. I get U1R. Now, if I multiply this term by R, I'm going to get U1R squared. And if I multiply the next term by R, it'll be U1R cubed. And if I keep doing that, the final term will be U1R to the power of n, because R to the power of n minus 1 times R to the power of 1 is equal to R to the power of n minus 1 plus 1, which is equal to R to the power of n. So that's why that last one is as it is. How's that? That's a bit rude. Here we go. Oh, it's just stopped working here. Okay, cool. Might be a little bit of lag there. Is that okay so far, how I've done that? Now I'm going to subtract the two terms from each other. So I'm going to go Sn minus Rsn, so the top row from the bottom row. So what will that give me? Well, in the top row, we've got U1 here. I can see it's lagging a bit, but I'll just try and deal with it. So that's just left here as well. But then I'll have U1R, and U1R here will cancel out, right? So these two will cancel out. Similarly, U1R squared will have a match up U1R squared here as well. So those two will match up. And in fact, they will all match up. Everything in the top row apart from the first term will cancel with something in the bottom row, except for U1R to the n. And so if I subtract these two things together, I will get U1 minus U1R to the n. Oh, man, it's probably not worth it, just what I'm doing here. I'll just try a little refresh on the browser, and if that is not enough for it to go, no, I think it's actually Vivi that's causing the issues. Okay, hopefully that's a bit more stable now. So we're left with Sn minus Rsn equals U1 minus U1Rn. Okay, so we're left with that nice, simple formula. So if I take a common factor of Sn out here on the left, I'm left with Sn outside of 1 minus R. And if I take a common factor of U1 on the right, then I'll be left with 1 minus R to the n inside the brackets. Now, if I divide both sides by 1 minus R, I'll get Sn is equal to U1 outside of 1 minus R to the n all over 1 minus R. Boom! That's the formula. Okay, and again, if I multiply top and bottom by minus 1, I would get the other form of the formula as well, just like that. That's pretty good, isn't it? Do you need to know this for the exam? No. Will you be tested on this in the exam? No. It is. I just find that with many students, understanding how the formula is derived helps it stay solid in your head. Florence. Figured it out?
Yeah.
cool. By the way, for all of this to work, what can't the common ratio be? Oh, 0 makes for a boring sequence, but technically you could do that and it still would work. 1, yeah. Why can't it be 1, Maddie? It'd be boring, but that's not the reason why it doesn't work for this series formula. What happens if I substitute 1 in for R in the series formula? Eve? Not quite. Jack, did you say something different? It becomes 0 where? Izzy? No, 1 to the power of anything is 1. Jack was closer. Yep. The denominator would be 0. And we can't have a fraction where the denominator is 0. So I haven't written that down, but you'll see it on most formula sheets. You'll always see the series formula with a comma, R not equal to 1. Feel free to write that in if you want to, but, you know, I don't bother with it because when R is equal to 1, it's hardly a geometric sequence, to be honest. Okie dokie. Moving on. This is the theory that you do need to pay attention to. I'll give you a chance to write this down, then we'll go for it. Okay, so key points. It's going to be geometric because of the 5%. It's growing by 5% each day. It's going to be a geometric series because you're given the total number of shoppers over a period of time as opposed to the number of shoppers on a single day. The question is how many shoppers were at the mall on the first day. Slide 7 has the 4 bits of information that we either need to find out or are given in the problem. Which one of these will answer the question, how many shoppers were at the mall on the first day? Iris, you got a 1 in 4 chance. Do we need to answer the question, how many shoppers were at the mall on the first day, do we need to find U1, R, N, or Sn? Yes. So U1 is our question mark. We don't know that yet. R is the ratio. Look at the question, work out what value implies multiplication or division, I suppose, and then isolate that as your R. Rupert, can you tell me what you think R is? You are extremely close, but not quite there. You've identified the right number, which is the 5%. You've converted it into a decimal, which is 0.05. But if I multiply a number by 0.05, I'm going to be shrinking it, right? Do you want to correct yourself? Yeah, it kind of works in the finance field as well. You're nearly there. Someone else who knows it, Maddie, 1.05. So the 1 is like the 100%. So the growth factor is 105% or 1.05. You got us nearly all the way there, Rupert. Thank you. What is N in this scenario, Emmy? Yes, perfect. And what is Sn in this scenario, Florence? Good year that, 1258. Great. So there are all our facts. Now we can substitute them in to solve the problem. So therefore, Sn, which I'm going to write down as 1258, is equal to U sub 1, which we don't know. So I'll leave it there. Outside of, which one should I use? R to the n minus 1 or 1 minus R to the n? The other one. Okay, 1 minus R to the n. You use that if R was less than 1. It's only just above 1. So you're going to use 1.05 to the power of 10. There's n. Minus 1. Doesn't matter. What happens if you chose the other one? Will it matter? Not at all. You'd have a negative on top, you'd have a negative on the bottom, and they would cancel out. 1258 equals U sub 1. 1.05 to the power of 10 minus 1 all over 1.05 minus 1. So I reckon I'll do part of it on the calculator. So 1.05 to the power of 10, and then subtract 1, 0.6288. Now, I'm going to leave my calculator there because it's got more decimal places I'm going to write down, but 0.629, I suppose, would be the smart thing to write. No, that's just next to U1. So 1258 equals U1 multiplied by 0.6, I can't remember, it was so long ago, 629. And I'm feeling brave today, and I'm going to work out 1.05 minus 1 in my head. I'm just pausing for the video so I can hear gasps around the room. That's good. So 0.05 on the bottom, okay? Now I'm going to use my calculator to work out what U sub 1 is. I'm going to do it in one step on my calculator, but just to explain verbally, I'm going to multiply 1258 by 0.05 to get rid of the denominator, and then I'm going to divide out by 0.629 to get rid of the bit in front of U1. So multiply by that, divide by that. So on my calculator, I've got 1258. I'm going to multiply by 0.05, just doing it in one fell swoop, and then I'm going to divide it by 0.629. But instead of writing in 0.269, which is not quite decimally right, I'm going to go up, use my up arrow on my calculator to highlight the value, which is all the decimal places, press enter, and then I can press enter again, and it will give me the answer, 100.02. 100.02. But that is a dumb answer. You can't have 0.02 of a person, and if you can, you should be ashamed of yourself for, belittling people. 0.02, so we round it to i.e. 100 people. So this, belittling people, I didn't even mean to make a joke, but I did. Okay, 100 people were on the first day, would be the conclusion reached there. Am I making sense? Do I have any questions? You look like you have one. Debatable. Really good question. I'm going to repeat it in case your voice wasn't picked up on the video. Surely we should round up. 100 is not going to be enough. In this sort of context, I would say that because we're not looking for a limit as such, 100 is probably reasonable within the context. If I was trying to say at least how many people or whatever else, maybe I would choose differently. But in this context, 100 would be fine, I think. Okay, I'll leave the video there.